Hello, I'm Atindra Chaturvedi. In the previous section, we covered vSphere 6 Advanced Networking. In this section, we will look at working with vSphere 6 virtual machines. We are going to take a look at configuring advanced vSphere 6 virtual machine settings, a new vSphere 6 feature which is creating and managing a multi-site content library, and of course, since we are living in the age of cloud computing, we have to understand how to configure and maintain a vCloud Air connection, which is the public cloud provided by VMware, and the ability using vCenter and some additional products to actually create your own hybrid cloud. In this video, we are going to configure advanced vSphere 6 virtual machine settings. We will look at configuring virtual machines for virtual graphical processing units. We will look at direct path IO as well. We will go through the process of understanding what it actually means, as well as SRIOV. We will configure our VMs to utilize modern multi-core CPUs. And of course, we need to understand among the various VM configuration settings. We look at only at the advanced settings. Again, the assumption of this course is that you are very familiar with basic vSphere 6. We are looking at only the advanced features of vSphere 6. We will also interpret and manage advanced VM settings. Again, they are quite important because in certain cases you really need to use them to be able to fine-tune your environment. And we will end this video with a hypervisor command line lab for virtual machine management. So we are now at the NVIDIA website. This is one of the major vendors for GPUs. I have no connection with NVIDIA. I'm simply using it as an example. So what you see up on the screen is the NVIDIA Grid vGPU software release, and this is your driver, and the operating system is VMware vSphere 6. So what I have done is I've previously downloaded this device driver to show you what the process is. And this is my download directory, and after unzipping the download, you see there's a quick start guide there, some release notes. The one we are interested in are these two. This is the offline bundle that can also be used to patch ESXi hosts, and I think we are going to be doing a section on this as well in this course. The .vip file is the virtual infrastructure bundle, and this is the file that we are going to actually load into ESXi. To load this file into ESXi, we have to go to the vSphere web client and upload it to a data store. So we're now at the vSphere web client. We're looking at the host 192.168.0.201. We will go to its data store, and we see there are two data stores. The one that we are interested in is this one. I click on this and I browse this data store. You can see that there are some directories here. These are for Ubuntu systems. This is for an instant management system. This is for a software controller from Cisco, and here's another Ubuntu. So the data store basically contains virtual machines, and these are the virtual machine folders. What I need to do is to upload by clicking on that icon, and I then browse to this one, and I open that, and the process begins, and that is now copied. And as you can see, that wib, I'm going to move these out so you can actually see that this is the .vib file. I'm going to do it even more. So here's our .vib file up here, and that's the .vib file. So we have a .vib file now available in the data store 1 with the 2 in parentheses, because in this vCenter I have multiple data stores called data store 1. Now this is where I would like you to recall our experience from the prior sections where we actually went into the ESXi shell and did some command line, because it's now time for some command line activity. So what we have done so far is we have downloaded the NVIDIA device driver, which for vSphere comes as either as offline bundles or as a wib. We then took that wib and uploaded it into the data store for that ESXi host on which we want to then install it. So now we're going to move to the command line of that host on which we want to install the NVIDIA software. I'm now logged in using my secure shell into the ESXi host 192.168.0.201. Now, if you recall, we do cd/vmfs/volumes, do an ls, and these are our data stores. I cd over to data store1, and I do an oh, it can't cd that. I misspelled it. Here we go. Okay, I do an ls on that, and as you can see, the web file is now available to us, and we have the full path for this file as well. The full path for the file is, of course, /vmfs/volumes/ and we can replace this string with data store1 within parentheses 2, and then of course the NVIDIA file name. So the command that's used for installing software WIBs, virtual infrastructure bundles, are these ESX CLI software WIB. When I hit the enter key, I get the options. I can get installation about specific installed WIBs. I can install a WIB. I can list the existing WIBs. I can remove WIBs, and I can actually update installed WIBs to newer packages. So let's take a look first at, clear this. Let's take a look at software WIB list. And this lists the various WIBs that are installed in the current ESXi 6.0 hypervisor that is running on this host. We will do this again with more. And you can see at the top, you have the name, you have the install date, and then the version, the vendor, and the acceptance level, and these are all VMware's certified. So the very first ones are, up at the top are some of the stuff for the ATADIS, AMD. There are a whole bunch of other ones as well. This would be for USB, I believe, the EHCI, and so on. Anyway, these are the WIBs, and the versions are here as well, and then names are up here also, right? And when I press space, you can see these are all the ones that have been actually loaded. Okay, so I'll clear this again, and we are now going to do ESX CLI. Better to do it a little bit differently. Just Control-C out of this. ESX CLI software WIB install. I hit the enter key. It says there have been no WIBs specified. You need to specify WIBs basically with a -n or the WIB URL with the -v. Okay, so we are going to key in ESXi software WIB install -v, and then we are going to say /vmfs/volumes/data1. If I spelled that correctly, yes, slash, hit a capital N, I tab, and that is filled in. Okay, so we're going to do a ESXi software install with this file, and we hit the enter key, and it is going to come back saying there's a maintenance mode error. That maintenance mode is required to remove or install this. Okay, do you recall the command for moving this host into maintenance mode? It's ESXi system maintenance with a capital M mode. No, this is, I spelled, I have extra I here. In this mode, set -e true. Okay, we will now do a get of the maintenance mode, and it's enabled, so it is now in maintenance mode. So we retrieve the WIB install command again, and we hit enter, and this only takes a few seconds while it installs the WIB. Took about 10 seconds, and the installation result is it's finished successfully. And this is really important. Reboot required is false, and the WIB installed was the NVIDIA WIB. and there were no other webs removed or skipped. Sometimes there are some prerequisites that are out of date and so on. But anyway, in this case, this was a clean install. We can do an ESX CLI software web list, and we should actually do it with a pipe 2 more. So I retrieve it, and you will see the web up here at the top. Now I have selected it for one reason, which is that I want to now show you how to remove it. ESX CLI software web remove. And what I have to do is, you can do a dry run. This is really interesting. It performs a dry run, reports the operations that would be performed, but does not change anything. So this is really useful sometimes because you're not sure whether this a new web, when it's being removed, would actually create other kinds of problems. And dash maintenance mode pretends that maintenance mode is in effect. Otherwise, remove will stop. So what I usually like to do is to actually put it in maintenance mode. It just takes a second extra, anyway. The no live install is okay as well. So all we need is basically we need the nib name, right? So we need to get the web name again by doing the list and piping it 2 more, copying this. That's the web name. Control C, remove -n. And now we need the web name, and I hit right click to paste it in, and I hit the enter key, and this will go through its process, and the operation finished successfully, and it did not require a reboot, and webs have been basically removed. So this is the process that you actually follow. I actually went through the entire process of downloading the actual driver, and then unzipping it, finding the .web file, uploading it to a data store. I showed you on the command line how to retrieve it, and then actually go ahead and install the web, list the web, pick it up again, and remove it. So all we have right now is to remember to set this host back into operation, so out of maintenance mode. So ESX CLI system capital M, maintenance mode set dash enable false, and then I do a get just to be sure that it is out of maintenance mode, and maintenance mode is disabled, and we are done with this. Now I do not have a physical NVIDIA GPU installed, so otherwise I would have to reboot the hypervisor, and then I would be able to assign GPUs over to virtual machines. But at least we were able to take you through about 75% of the process, especially in the light of being able to manage the installation and removal of virtual infrastructure bundles. We change gears a little bit and look at SRIOV. So basically, it's a idea that was very good in its time. It's almost 8, 9, 10 years old, something like that. The idea was to be able to use one physical card and have multiple connections through it. An early form of virtualization, in a manner of speaking, IO virtualization. Now, the cards that I have, as you can see, I'm on the physical adapters for that host. Cards I have do not support SRIOV. There are very few cards that do that, and there are very few systems that actually use it because the use cases are few and far between. I mean, now we have just maybe 2 or 4 10 gig bits per second NICs attached to servers, and almost everything happens through that, including storage IO as well. So it's kind of an old idea. So the fact that I'm not able to show it to you is not too much of an issue, frankly. Now, the next one that we're going to look at is direct path IO. Direct path IO, the idea is that we take a virtual adapter. So in this case, I have, say, how many? 2, 3, 4, 5, and then 2 more. So we have 6 virtual adapters available from 0 and 1 are attached to vSwitch 0, and then I have 4 other adapters, 2, 3, 4, and 5, and these are attached obviously and being managed right now by the ESXi host. The idea with direct I/O is to be able to pick these adapters, 1 or 2 of them, or any number actually that you need, and then remove them out of the purview and the management of ESXi and make them direct, which is where direct I/O comes from, make them directly available to a virtual machine inside the ESXi host. That obviously requires a device driver for that NIC card within that host, and the process goes like this. I have to select, I have to go through a process of taking these NICs, the ones that I want, removing them essentially from ESXi, rebooting the ESXi system, and then I will go into one of my virtual machines that has been powered off, and we will go into the add PCI device, and you will see that it will be available at that point in time. So with that said, let's go through the process. So the first step is to get these out of the control of ESXi and make them available directly. So we go into settings, scroll down, see the PCI devices. The GUI is kind of interesting. You kind of sit here and wonder what's going on. Just click on the pencil, and you will see all the PCI devices that are actually available on this host. You can see here are some cards here, single 1 gigabit cards, and then I have a whole bunch of MegaRAID SAS stuff. Those are all virtual functions, I'm pretty sure. And then I have 2 of those of my VM NICs, so these are the 2 that are currently being used, right? So when I try and use these, it would be problematic. Let me just not fool with VM NIC 0. I click this, right? And then when I reboot it, this available pending means reboot will actually go away, but I don't want to interfere with any one of these. All I want to do is to look at another set of adapters, and I clicked on one, but both came through, and one of the reasons is that they're being managed by basically the same PCI root chip, and when you click on one, you get both, and my Intel card, I guess, is like that. But for our purposes, that doesn't matter. So what we've done is we'll now have 2 of our NICs available to be used to directly connect to virtual machines after I do the reboot. I click OK, and it's going through its process here, and what I'm going to do now is to pause the recording to do a reboot, and we'll come back to this after the reboot is complete. So I completed the entire reboot process for 192.168.0.1, and as you can see, the direct path IO PC devices available to VMs, these 2 are now actually available. So what we can do now is, let's just look at some of the details here. Device ID, sub-device, the vendor is Intel, the vendor ID is 8086, which I did not know, but I think it's really interesting because some of you may remember 8086 was probably the most successful of the early chips that Intel made, and after that came the 8088 as well for the IBM PC. So it's interesting the vendor ID is 8086. I did not know that. So we now have 2 direct path IO devices available to VMs. We pick up, say, this Ubuntu VM, and right click on it. We do an edit settings on this Ubuntu VM. Okay, we select a new device from here. We select a PCI device, and we say add, and here we are. We have those devices show up here. Let me just move this aside a little bit. So it's all zeros with a 1 and a 1. So here's one of them, and there should be the other one with the 1, right? So 0 and the 1. And so these 2 are available. I can select one of these and say I have to reserve all memory. That's very important to do. And then I say add. Okay. So that's a new PCI device, and then I add another PCI device, which is the next one over, and I click on add as well, and basically I click OK, and that's how that works. So when I reboot this, assuming that my Ubuntu system has device drivers for that, I will be up and running, and that these 2 NICs are going to be directly available to that Ubuntu system. I'm going to right click on this, edit it, just to clean it out, because I really will not be using these directly the way they are. Okay, and I will delete them. And those devices are gone, just to verify it. Still see one of the PCI devices, and we remove that and we do that. So that's how it's done. Those devices are still available. So what I'm going to do now is to again, I guess, select one of them, edit it, and if I deselect any one of them, then both will go away. So they are not available right now because the ESXi host has to be rebooted to find them again. But we'll get to that later on. So I click OK, and then those devices will basically, they are still available now, but will not be available after the reboot. We are now going to look at configuring VMs for multi-core CPUs. So let's just take a look at the summary for this host. It's an Intel Xeon processor. It's pretty high speeds. It's running 8 logical processors, but that's because of hyperthreading. It is one socket, 4 cores. That's what that is made up of. Interestingly enough, you see I only see 4 NICs instead of 6 because 2 are now direct IO PCI devices. I had just rebooted it, as I said before. It gives me the warning that I need to reboot to get my other 2 NICs back. So we have we're looking at logical processors right now. So we have 8 logical processors available to use in our virtual machine. So I right click on that and I edit settings. And we're going to look at basically the virtual hardware. So right now it's a 1 CPU, cores per socket 1, and because it's Ubuntu at this point in time, it kind of knows that that's how, that's the max, that is how this would work. Okay, we can cancel out of this and look at this system. This uses a lot more CPUs. So this is a 4 CPU virtual machine, right? 4 cores per socket in 1 socket. Nothing is reserved for this. CPU ID masks again are really old-fashioned things in the sense of virtualization. This used to be necessary once upon a time, but now things are just so much simpler, and especially in a production environment, you would never go around faking out CPU IDs by doing different kinds of masking and stuff like that. So I guess in some cases it's necessary, but in my experience, it never has been. Hardware virtualization, expose hardware-assisted virtualization to guest OS. I'm not going to change this because that's the way this system was actually installed. Scheduling affinity, so yes, hyperthreading is active and 8 logical CPUs are available. I can select logical processor affinity, so I can say basically, this is going to run on CPUs 1, 3, 5, and 7. And what would happen is that only when those CPUs are available, that's when the various threads for this application would actually run. Obviously, it'll create havoc with the scheduling, so one never does anything like that. CPU MMU virtualization, memory management unit. Again, it's best to leave it as automatic. You can do software and MMU, but it's terribly slow because its software is used for the instruction set and the virtualization. Again, very old-fashioned, probably what they did in the old days before the Intel processors and the AMD processors, supported hardware virtualization constructs and instructions. Again, combinations of that, and here we force hardware CPU and MMU. So you use the Intel VTX or the AMD V instruction set for virtualization, and then the RVI for the MMU virtualization. But again, it's best left as automatic. And that's basically it. A couple of other things to look at here is, in this host that I have, the ESXi host is 1 socket and has 4 cores. So I came across a virtual machine that required a minimum of 6 CPUs. So I virtualized it and I gave it 6 virtual CPUs on my 8 hyper-threaded CPUs. And that virtual machine had all kinds of problems. It is because the 6 virtual CPUs did not map in terms of scheduling very nicely to the 8 that were available. It was just not, a proper factor there. So what I did was I increased the virtual CPUs for that virtual machine to 8 virtual CPUs, and lo and behold, that virtual machine works absolutely beautifully on my system. And in fact, we could take a look at that virtual machine It is the EPIC EM2 virtual machine. We can take a look at the edit settings for that. And since we're looking at multi-core CPUs, you can see I used 8 CPUs, and this just worked absolutely fantastically. This requires massive resources, and ESXi just handles it tremendously well. Let's now look at some of the other VM configuration settings. Let's look again at our EPIC EM2. I right click on that and I edit settings. Let's move away from the virtual hardware, look at the virtual machine options. So of course you have the VM name, and you can specify the data store where the VM config files are, and the working location and so on obviously is in this directory. You can change all this. There's no need to change it. In this case, this was installed as a virtual appliance, so those are the settings it likes, and I think it makes sense to leave the working location, folder name exactly the same as the name of the virtual machine. Otherwise, it becomes difficult, to say the least, to find things when you need to. The remote console options. So one can limit the number of simultaneous connections to this machine. Now this is really important. We can do it with an advanced setting as well. But usually this should not be more than 1 or 2. And the reason for it is this: if an administrator is logged into this machine and you have more than one administrative sessions allowed, then it becomes so this is basically the number of simultaneous connections. But then again, depending on the type of machine you have, you may or may not want simultaneous connections to this machine. So just be aware of that, and get the right number in there. We have VMware tool settings. You can specify what the power operations are. So when you press that stop button, what should it do? Shut the guest down or power off? Obviously the right thing to do is shut down the guest, and usually the virtual machine will then stop. Same thing again, recycle would be restarting the guest. So to do a restart, shut down, restart, probably in a Unix or a Linux environment. When do you run the VMware tools scripts? This is probably the right way to do it. I don't think we would like to check and upgrade VMware tools before each power on. It makes no sense to do that. This one is interesting: synchronize guest time with the host. A lot of people use this. They have the ESXi host with the NTP server. What actually makes more sense, if at all possible, and it is possible in the case of this virtual machine, EPIC EM, is there are multiple NTP servers I can define from within the virtual appliance. So this virtual machine appliance actually does its own NTP directly with pool NTP servers here in the US. So that works very well. You can synchronize the guest time with the host as well, but if you have the option of directly synchronizing with an NTP server, much better to do that. Let's look at power management. So how should the virtual machine respond when the guest OS gets a standby for power management? You can either suspend the virtual machine, or you can put it in the OS in standby mode and leave it powered on. Just leave it in standby mode, leave the virtual machine powered on, because when it goes out of standby, it just comes up much more easily, and in a much cleaner way rather than suspending. It's better to put the OS into a standby mode and quiesce it. The boot options. Changing firmware might call the installed guest operating system to become EFI or BIOS. This is a virtual appliance. It's using BIOS, so we'll just leave it alone. The boot delay, I like to always do a slight boot delay. Force BIOS setup. This I'm sure you've used quite often for the next boot. Next time the machine boots, you force entry in there. Failed boot recovery, automatically retry after 10 seconds. I guess that's fine, but if it's not rebooting, there's a problem somewhere else. The advanced settings are basically disable acceleration, because by default acceleration is enabled, so it uses all the hardware capabilities on the processor to accelerate the virtual machine as much as possible. But sometimes when doing installation, or if you have other virtualization devices basically in there, sometimes during the installation things really don't work that well, so it's advisable at that point to disable acceleration. And when the virtual machine is actually booted up first or second time, you can then disable that you can then turn it back on again rather. So disable it while installing, and you can enable it back again after everything is working. You don't usually have to do it if you don't have to do it, okay? But if there are problems installing, then that's one way to do it. Enable logging. Run normally is the best way to actually do this. The swap file location is the settings of the cluster or host, so that's for the swap file for the virtual machine. You can store it in the virtual machine directory as well. There's a lot of I/O going on there. Usually one sets the cluster to have a swap file location that is on a disk that is not going to be part of disaster recovery, or is not being replicated somewhere, because obviously you really don't want to do that. But again, these are all basic settings. I'm not going to talk any more about that. Latency sensitivity is very interesting, because with the virtual appliances for voice over IP, you need very low latency, and even video servers and everything else, they don't run on dedicated hardware anymore. Everything runs basically on standard hardware, so they can be very sensitive to latency. Now, I'm told it is recommended that not to use the low and medium in ESXi 6.0. I'm not exactly sure why. I would leave it as normal unless there was a reason to make it a high. Actually, the APKM installation guide recommends setting the latency sensitivity to high. I haven't done that, and it seems to work just fine. So, use it when you really need to. We're now going to look at some configuration parameters. By clicking on that button, you get the various PCI devices that are there. That's your NVRAM file there. CPU cores per socket is 8 with hyperthreading. Then we have replay is not supported in this, because I guess it's because of FT, fault tolerance is not there yet. The swap file is here in VMFS volumes. What else do we see up here? These are the host CPUs available. Remember, this is 8 CPUs here. I have not set EVC compatibility yet, so it's not relevant. Some stuff about VMware tools and so on. Now, here is my view on these configuration parameters. While it's nice to be able to manage some of them by just adding a row, adding the name here and then the value, this again goes back to what I call the earlier days of virtualization, when individual virtual machines had to be tweaked with very specific parameters so that they would function well under the hypervisor. Last 5 or 6 years, I have hardly ever made any change in the standard configuration. And now, of course, the world is changing to virtual appliances. So you just load in the virtual appliances, it has the settings, and off you go. And usually I've never had a reason to make changes. There have been just a few. There has been one that has either I usually put in when I have a Linux virtual machine installed, and that has to do with the delay for the keyboard, because what happens is it senses that the key has been pressed and repeats the key, and you get very irritating behavior there. So there is a setting which is called keyboard.typematic min delay that one could actually put in there. And just to show you what it is, and I have a whole list of others that you might want to look at, but this is the one that I think is reasonably useful, but in a Unix machine. So it goes like this: keyboard dot type matic min delay, and I have to put in a value of, say, like 2 million for 2 seconds. 2 1 2 3, so that's 2 million. So keyboard.typematic min delay is now 2 seconds, and I basically add the row. I mean, that's really all it is, and I click OK. So I made a change that really is not going to affect this too much. But again, that capability is available if your software vendor or your VMware support organization asks you to make these changes. Of course, by all means, you should do that. But try and avoid making these changes, just because it really does not make a difference now. And again, in a production environment, it's much better to keep it really simple and as plain vanilla as possible. It just makes for an operation that's much more easy to support. So after looking at the different VM configuration settings and of course configuring the VMs for multi-core CPUs and looking at the GPUs and direct path IO, SRIOV and so on, let's take a look at interpreting and managing some advanced VM settings. So here is a list of settings one could conceivably use. And the reason I'm very hesitant about this is simply that in my experience in the last few years, any extra setting over and above that's in the virtual appliance or even from VMware support is hardly ever necessary. We've come a long way since the early days of virtualization, but just in case. So for security purposes, you could have this isolation tools copy disable and isolation.tools paste disable. So if you set these, then you are able to disable copy and paste into the console. So if there's some critical information, some security oriented information out on your console, you can be sure that nobody is copying and pasting it. Then same thing with isolation device connectable disable and isolation device edit disable. So for example, connectable devices, a non-root user can connect them and edit their capabilities. By putting these configuration settings in, you're able to disable that capability. Remote display max connections. This is very useful, I think, anyway, from a security perspective, because if you have more than two of these, then what could happen is that if there's an administrator sitting at a console, then somebody else, if a second remote console is allowed, they could be actually snooping in there and be aware of what was actually entered. But then again, there is a shell.log. If you look at the /var/log in the shell.log, if someone is working in the ESXi shell, then of course, all the commands are logged. But if you're in the graphical user interface, obviously that's not logged in the, that's not logged. So you could have somebody trying to peek over your shoulder when they really should not be. We looked at keyboard.typematic min delay already. The log.rotate size and the log.keepOld are interesting as well. So this is for the virtual machine logs. If you are logging, you set the size of this log. It's stored in the same directory as your configuration file. You can change it. There is another VM setting, log dot, I believe it is swapdir, log.swapdir. You can set it to actually log to a separate directory. And then log.keepOld is number of logs, so it'll keep 3 or 4 logs. I believe the default setting is to keep 6 logs and then rotate basically. And sked.swapdir, this is for specifying a directory where the swap file for the virtual machine is actually kept, so you could put it off somewhere else on a separate LUN or a separate storage device that's not being mirrored or replicated or any such thing. Up at the top, the title says some commonly used advanced VM settings. Honestly, none of these is really commonly used. We are in the world of virtual appliances. Only if you're really tweaking, only after everything is working really well, you still want to tweak something. I mean, you can work with these, but really my advice is leave well alone. If it's all working fine, don't work with this. Don't make changes when they're not necessary. So with that, we have looked at configuring virtual machines for virtual GPUs, direct path IO and SRIOV. We also saw how to configure VMs from multi-core CPUs. We differentiated among the VMware configuration settings and interpreting and managing advanced VM settings. And now we will take a short look at a lab for command line for virtual machine management. So here we are logged in again into 192.168.0.201. And let's take a look at our ESX CLI VM. And there's one namespace available, which is called process VM. Okay, and we can either kill or list. Let's do a list. And there are no VMs running on this. So I'm going to go back into our web client and start some virtual machines up, and then we will come back. Let's take a look at the VM process list one more time. Much better. There are 3 virtual machines, looks like. There's this Ubuntu machine 201-1. There's a Ubuntu 201-2. And there is the Scrutinizer incident response system that I also use for my NetFlow connector. Let's see the information that's up here. So for the Ubuntu, there's a world ID. This is not exactly a process ID, but it's an ID for the entire collection of various components and processes that make up the whole virtual environment here. So this is the ESXi term, the world ID. It's kind of aligned with the process ID on Unix and Linux systems. Okay, same thing again, VMX. It has a certain UUID and there's a display name, and of course the configuration file, which is a .vmx file. It's on VMFS volumes, and we know how to read this now, right? So go to VMFS volumes and you're able to find out what's there. So nothing much in here to see apart from this. Let's look at the kill command and process kill and see what it needs. The kill command, as one could guess, is used to forcibly kill virtual machines that are stuck, not responding to normal stop operations. So you can specify the with the -T, you can specify a soft kill, which is basically a SIG term, or you can do a SIG kill, which is a kill-9 for Linux folks. You could also use the word force, in which case, if all three fail, it's interesting. If all three fail, then a reboot is required. Well, and so obviously you need the kill type and you need the world ID, and it is pretty straightforward. From the VM process list, you can obtain the world ID, and you can specify the type, and you can kill it. And really, these are the only two commands that are available because VMs are supposed to be managed from the clients and not really from the command line. Thank goodness for that. Now, an interesting command is /sbin/vm dumper --help. So this command can be used to do interesting things. You can get a screenshot, okay, or you can send it non-maskable interrupt. And the reason one would do it is if you wanted to send a hard kill into a virtual machine, this would actually kill that. Now, with my Ubuntu, especially the version of the Just Enough Ubuntu, which is available from www.pqr.com, it's a tremendous Linux implementation. I actually just love it because it's small, it's elegant, it's clean. I can use it for containers and everything else like that, and it starts and stops really, really fast, and yet it is a full Ubuntu implementation. So it's a great Linux distribution. So when I send an NMI to one of those, it actually complains and says something like, what are you doing to me? Are you trying to send me some kind of a power management control command or something on those? And we can actually take a look at that just to show you. So again, the key ones are, of course, the NMI and screenshot. The rest of the stuff I would leave up to VMware support, to be honest. So here we are. We are going to now see if we can find the console for one of these Ubuntus. And I'm going to log in here. Clicking on it. And here we are in that screen. Now, what I'm going to do is to go back into the command line, which is here. Okay, do ESX CLI VM process list. Now, I believe I used the 201-1, so 37311. Let's just verify that. This is the console for 201-1. That's correct. Okay. We're going to go back to this. So our world ID is 37311. I hit clear, ESX CLI VM process kill -T4 type force, and then we can say -W, I believe it is for the world ID 373. If I have keyed this in correctly, we shall see if there is some response up here. And with the force, it was actually terminated. So that worked pretty well. So in this video, we've looked at how to configure VMs for virtual GPUs, direct path IO, SRIOV. That was quite an interesting process. It did require a reboot in the case of direct path IO. did not require a reboot when we installed the VIB, the virtual infrastructure bundle, which is a device driver for the GPU, the NVIDIA GPU. Multi-core CPUs need to be basically factors of the actual number of physical CPUs available. So if you have 8 CPUs, don't specify 6 CPUs, virtual CPUs in your virtual machine. Make it either 4 or 8. We differentiated among other VM configuration settings, very few and far between that are really needed nowadays. We looked at interpreting and managing some advanced VM settings, more to do with logs and acceleration and so on. And then we did a brief command line lab for VM management. We looked at the command ESX CLI VM process, list and kill, and the /spin /VM dumper, with which we can get screenshots as well as we can basically kill and dump. Okay, so it sends a non-maskable interrupt, and we can look at the dump files for that if they had been set to see what actually came out of that. So this is where we've come. We have looked at just about everything that we had to do here, and let's see if we can find what we are going to be looking at. The next video is about creating and managing a multi-site content library. I think you will enjoy that, and I look forward to seeing you in that video.